Hello, friends. We are back here with the 1970s Fender Bassman 50. Where we left off last was removing the power tube socket here because it has a nice little crack in it. If you can see that right there. And so unfortunate, but things like that happen. So we removed that and I purchased a replacement, but I didn't realize that the replacement had these flat lips here, whereas the original has this kind of step down. So we had to order a new replacement. It took a little bit, but it is here. And you can see this one has the little step down just like the original. So we should be good to go there. Quick test fit, we'll just confirm. So we'll go just like that, and it fits nice and snug, so that will be perfect. And then we've got all of these leads to connect. We've got the heater wires here. We've got this to the output transformer. We've got these two wires. All of that will be connected onto the pins. And then after that, the last thing we have, if I remember correctly, is the 3-prong. And then I think we're good to go ahead and bias this amp and finally turn it on. So super excited. Hopefully we can get this done tonight. That is the goal. I will say it is extraordinarily hot here in Southern California. And normally we have a nice breeze and it cools down at night, but it is not doing that. So it's currently 83 degrees and climbing in the garage right now, and it is very late. So that's the world I'm in right now. So if I'm a little sweaty or slow or whatever, that would be why. Okay, all of that out of the way. Let's go ahead and get the little bear claw here installed, and then we can go ahead and fire up the soldering iron. So here we have the new tube socket installed and screwed in nice and flush with the body, exactly as we originally wanted. So now we're going to go ahead and start populating the pins. We're going to go ahead and just really quickly solder these two, and then everything else I'm going to kind of do in a specific order that I think might be best, though we'll see on that. So we'll do these two, and then I'm going to install the cap, which goes, you can see this one right here, which goes from pins, 5 to 8 to ground. So we're going to just go through 8 to ground, get this ground connection with the big soldering iron, and then kind of have it out of the way and start installing everything else and slowly build it back up. We are going to attempt to install the original 470 ohm 1 watt as well as the 1.5K resistor here. We're going to try, and if we can't, then we'll probably just remove them from both tube sockets. But I would like to attempt to do that because they both tested fine. So I'd rather keep those all original if I can. All right, with that, let's go ahead and solder these two wires in. Now it's worth noting that the original, these were never touched before, and even still they have little burn marks on them, which just shows how fragile this wire is. So I'm just putting this here to give me a little bit of pressure on the wire to hold it down, and I've got a little bit of a hook in it, so that's a really solid connection. So we'll go ahead and solder this on. Perfect. We don't need to, have a ton of solder on there. We can keep it nice and clean. We'll do the same on this one. Perfect. You notice I'm just barely on there, in and out, super quick, which is kind of exactly what you want to do. Okay, next we have the absolutely ridiculous capacitor here. You can see the crazy long lead. So this goes from 5 through 8. So like this sort of thing. But we're not going to connect that end yet. We're going to really just focus on getting this ground connection here. So I will see if I can use these to kind of hold it in place. And then we'll hit it with the big iron. So we'll have plenty of pressure down on this and it won't move once we hit it with the big iron, and we'll be obviously avoiding all of these other wires in the way. So let's see if the big iron is hot enough yet. Might hit it one more time. Let me just see if this cap is crazy hot. It's not. So let's add a little bit more solder and do it one more time. There we go. All right, I'm nice and confident in that solder joint now. Now there's nothing super critical there. It's just the death cap on one side and then this cap on the other. But I wanted it to look, you know, basically like factory, which you can see right over there. And that looks pretty solid. So now we can go ahead and let go of it with our little clamp. Get this out of the way. Perfect. Now, real quick, if you're wondering what, you know, it's got all this kind of black on it right here, that is just flux. You can see from the original solder joints, it's got it as well. And that will literally just scrape off. So that's nothing to worry about. You can actually see all these little flecks everywhere. Those are just flecks of that in the chassis. So that's not a big deal. It's, you know, basically an aesthetic thing. But we've got this done, so we can kind of spin that up and out of the way for right now. And let's go ahead and get this lead that was tucked out of the way. Now this one goes to pin 1, which is a very tight fit. And the other lower slot of pin 1 will go is where the 1.5K resistor will go. There we go. Beautiful. Okay, what do I want to do next? So let's go ahead and connect the pin 1 connection first. Gotta dodge some wires here, but should be fine. So now in theory it should hold, and it is. So now we can go ahead and connect the other end. I love when a plan comes together. All right. Now let's go ahead and install the 470 1 watt carbon comp. Again, tested totally fine. So this will be going to, where am I at? Pin 4 and 6. We'll use the top loops here. Not a ton of room here, but there we go. So now it's floating. It's not actually touching anything. But still has a good connection mechanically. Beautiful. That looks great. So then we can go ahead and get this cap to reach right over into the top of pin, what's that, 5, just like that. I have it arcing over so it's not actually resting on the resistor. Beautiful. Cool, I'm really happy with that. That actually, I thought it was going to be a lot harder. Not to say it was easy, it had to be very, very intricate and careful, but everything looks super solid. So now we just have the heaters. So we'll have these two going right there, and then these two going like that. So we'll go ahead and mock them up now. I don't know how much you guys can be able to see because it's such a tight, cramped area, but doing my best, folks. You can see it's already kind of melted the shielding on this from the factory, so it's definitely very tricky work. Once again, we got to dodge everything and be very careful. Okay, I feel pretty good about that. Let's go and do the other side now. There we go. Okay. Let me look it over carefully up close. Cool, everything looks good. So we can kind of bend these back up like they would have been originally. Sitting nice and tall and proud over the tube socket. And let me just reconfirm all the pins. So pin 1 would be this white lead right here plus the 1.5K, check. Pin 2 would be the heaters. Pin 3 would be dark brown cable off of the output transformer. Pin 4 would be the 470 ohm and nothing else. Pin 5 would be the other end of the 1.5K and the little cap here. Pin 6 would be the other end of the 470 ohm plus this white lead right here. Or I guess it's kind of like tan color lead. And then pin 7 would be the heaters. And then pin 8 would be the cap again going to ground. So beautiful. That is the tube socket all hooked up. So now we can go ahead and move on to the 3-prong cable. I've got a video where I show how I do a 3-prong conversion to a vintage amp like this on the channel. I will link it in the description as well as put it up in the corner for you guys. I'm not going to go over everything step by step and show everything here, but in short, you want to make the cables nice and long here, the individual strands, and you want to get a new strain relief, and you will install that over here. And then this is where it becomes really tough. Make sure you're doing it the right direction, like that. And typically I like to leave it pretty short, something along those lines. And then this is probably the hardest part, honestly, is just getting it squeezed tight and getting it through the hole here. There we go. So we got the strain relief through on that side. We've got our cables. So we'll have green for the ground. I think I'll probably loop it around a little bit like this. And then we'll put it into this connection here. And then we've got the neutral white and then the black hot. And so this neutral will connect here to the courtesy outlet, where we will also connect one of the leads. Let me see if I can grab it off of the transformer. So we've got this one right here. So we'll connect these two to the same little post on the courtesy outlet where we can get a nice solid connection. And just to link those two together. And then the hot lead is already to the switch. So we will have the hot from the 3-prong going to the fuse tip. And then from here should be going to the switch, which it is. So that would complete that. Now, as a reminder, always want to take out the fuse before we do anything near it. And I'm going to leave this long, I think. I really want to snip an original wire like this for no reason, because it doesn't hurt anything to have it long. So I might just wrap it around a few more times and then we'll connect it here. And yeah, I'm not really going to show that because I'd have to flip the chassis over to the side for you guys to get a view. But you get the gist. Pretty straightforward. So, all right, let's go ahead and fast forward to all of these connections being made except for the ground. And I'll show you guys that one since you can see it pretty well. All right. All right, folks, this is where it starts to get real. We've got this bizarre ground setup here. We're going to have to slide this in right in there just perfectly without hitting anything. And then we've got to maneuver the massive soldering iron at the same time. So this is going to be tricky. Now I am leaving the ground connection, the earth connection here extra long, longer than either the hot or the neutral. As I understand it, that is to code and what you're supposed to do. So we'll have it just kind of up and out of the way, something like this once it's folded or once it's soldered in there. But for now, we're just going to kind of push it out of the way like this. And really, I'm just going to have to slide this in and hope we don't burn the end here too much. So that's the plan. Now let's grab the big soldering iron, the beast. Now what I'm going to try and do is heat this up first, add some solder to it, get it flowing, and then we'll go ahead and try and hold it in. All right, so that is working well. See, here's the issue I always run into, right? It's the fact that what I want to do is grip onto this end so I have more of a closer point to push it in. But anything I hold this wire with here, when the wire insulation gets hot, it's just going to melt and indent into it. And I don't have anything that will stop that from happening. I guess what I could do is tin it even more so that it's hard right here. Let me try that real quick. I'm hoping this will do is gravity will push that down. All right, feels like it worked. This is definitely stiffer, so I should have better ability to push that in. All right, let's grab the big iron and give this a go. All right, it actually looked like it got in pretty far, but I'm going to add a bit more solder to this. Well, in doing that, I kind of did exactly what I didn't want to do, and it did smush the insulation a little bit. I'm good with it. I think it's going to be a very solid ground connection. That's not going to go anywhere. And it's actually, yeah, it's solid. So I'm okay with that. And that big iron really heats up the chassis. So we'll just kind of push this off to the side and have something along those lines. Now, what I do think I will do is silicone, the wire here just to kind of hold it in place, just so it's not flapping around in there. Now, this is a head, so it's presumably not going to, maybe vibrate as much as if it was a combo. But I kind of think that might be a good, just best practice for leaving this longer. So I think we're going to go ahead and give that a shot and just silicone it right here, just to hold it down a bit. And then obviously it clears the screw holes on either side, so that's a non-issue. And as a reminder, once again, you leave this longer than the other wires, part of code, so that if this fails and the wire pulls out, the last one to come disconnected would be the ground wire. So the other ones would pull out of their solder joints. In worst case scenario, these are much shorter, so if everything else being equal, this pulls out, the white wire will disconnect, the red wire will disconnect, and the ground will stay connected. So, and obviously that's important. So, because that would create a dead short if the hot wire touched the chassis while the ground was still connected, that would trigger the breaker, versus making the chassis have the full voltage. So there you go. That is that. So let me grab the silicone and install it there. I think we'll clean that area first as well. Cool. So now that that's on there, this won't move around as much. I think I'm just going to start doing that, honestly. I can't think of a reason why that would be a negative. Just holds it in place. Easy to remove. Not a big deal. Cool. All right. So now I think we can go ahead and grab some tubes and see if we can bias this thing. All right. So now I've got everything rigged up with the set of kind of donor 6L6 tubes here. And we will first just double check everything is good to go. And then we'll throw in the customer 6L6 tubes here. I've already tested with the current limiter to make sure everything seems fine on this tube socket, and it does. So that's solid. Now we're not going to set the bias with obviously these different tubes, but I just want to check and make sure everything is looking okay and close before we put in the customer's tubes. So let's go ahead and bring up the voltage. So interestingly enough, for some reason, I'm not showing any measurement on my bias probe here, which I don't understand. The power tubes are lit up, so that's fine. There is signal getting to the cab. So everything seems fine, but I'm not getting anything here. Now, my guess is it has something to do with perhaps this cap going to what would normally be, I believe, an empty pin on the tubes, or maybe those aren't empty, but they just go to ground. I think those just go to ground typically, but they don't have a cap bridging the pin 5 and pin 8 together. So I think it might have something to do with that, but I'm not 100% sure. So I've got to look that up real quick. And if that is the case, then we're going to have to learn how to do the biasing the old-fashioned way without a bias probe. I've never done that before. So, hey, maybe this will be a good learning experience for us. But very interesting. I'm going to go ahead and grab a guitar cable, though, and just confirm things sound okay just real quick, even though the bias, and it is set super cool. It's the coolest it'll go. So I'm not really concerned with these tubes being red plating or anything like that. I think they're actually set really, really cool right now. So okay, let's go ahead and do that. All right, confirmed. Both channels seem to work fine. So obviously we'll do much more in-depth troubleshooting and making sure everything is good to go when we're ready. But first, I need to figure out how to bias this thing. So I'll be back. Okay, I am back, and I have a method I'm going to go ahead and try. Once again, the Rob Robinette website is just fantastic. I will have a link to that in the description. It's what I use for the normal bias calculator that I typically use. And he's got on here an explanation of the output transformer resistance method for measuring bias. We're going to go ahead and give that a shot today. I put in the owner's tubes into the amplifier first and foremost. And then without the amp on, we are going to check the resistance between the output transformer center tap, which is this red lead right here. So you can see the output transformer, you've got this brown wire, this blue wire, and then this red wire. That red wire is the center tap. So you're measuring off of that. Grab the other connection. So we're going to connect onto that and then switch our multimeter into ohms. And then we're going to go ahead and check the two tubes at pin 3 and see what resistance we get. So this one looks like it's 49.4, 49.3, and then this one is 46.8. So I'm going to go ahead and write those down. All right, now with the amplifier turned on, after I get this connected, so we're going to connect this to the chassis, and then this is where things get very, very serious, so we want to be very careful. We're going to turn the amplifier on now, and then we're going to go ahead and check the voltages at this point, as well as the two pins on the tube sockets that we checked before. So let's go ahead and do that. And we're going to let it kind of warm up for a while, I guess. You're supposed to have the volume off. So we'll give that a shot. All right, so I think I understand this a bit more now. So just to recap what we did, so we measured the resistance from the center tap to the other leads off the output transformer here. So these brown and blue leads, we measure the resistance from this to the red lead here, which is the center tap of the output transformer. That gave us 49.4 on this one and 46.8 on this one. And then we measured the actual voltage with the amp turned on, which is like it is right now. We measured the center tap to be 444 volts. We measured this pin on this tube to be 443, and then this one to be 444. From there, we're supposed to divide. So we're supposed to divide the voltage drop. So in this case, it's 1. So from here is 444. This is 443, so that gives me 1. So we're supposed to divide 1 by the ohm rating, which was 49.4. So that gives me 1 divided by 49.4 gives me 0.020 basically, which would give me 20 milliamps. And then this one is a bit more confusing because you can't divide by 0. So if we were to just say that that was 1, so let me just mark this down real quick. So that's 20 milliamps. And then say this was 1. So it would just be 1 divided by, what did I say, 46.8, which gives me 21 milliamps. So that's where we're at. Now I want to go over to my bias calculator and show that the plate voltage is 444 volts. And then I'm showing that on his calculator, here in my hand, you won't be able to see it, but it is showing that for a class AB fixed bias, we want 70% or 60% is average, which should be 35 milliamps. And the max safe is 70%, which is 41 milliamps. So we are biased quite cool right now. To see what this gives us, we'll go the max range the other side. And now let's go ahead and remeasure. We won't have to measure the resistance again, but we will have to measure the voltage. So again, hand in pocket. Now, obviously, this is nowhere near as exact as if you had a multimeter that went further, that added decimal points, but I don't. So we're just going to go off of what I have here. So that puts us at 40 milliamps. So that is just under 70%. So this is perfect, actually. So we'll just back this sucker off just a little bit and check it there. But this should put us pretty close to our target of roughly 60%. Yep, okay, we're going to go with this. I think this is good because I know max is still safe. And so this is just backed off of max just a little bit. So we know all the way counterclockwise on the trim pot puts us at a very cool bias. And then maxed out, it puts us just about 70%, which is totally fine. So I think we're good. So now we're going to do a quick test just to make sure it works. It's really late, so I'm not going to play much, but just enough to confirm everything seems okay. Cool. It seems to work just fine. Okay, here's a good test. The master volume, if you guys remember from the earlier episode, it was very scratchy. Now I turn it, it makes no noise. So as I showed on the, I believe it was the previous episode or part of this series, I cleaned the eyelets and cleaned the board around the eyelets, and that got rid of any stray voltage in the board. So that seemed to have cured that issue completely. Not showing any static or anything here, which is fantastic. So I think we are good to go. Now we just need to go ahead and clip the leads off of the resistor on the bias pot there, since we know the range is totally fine, and I think we're good to go. Super excited. We'll plug it into, a cab and play a bit louder before the owner comes and picks it up, just to confirm everything is good to go. But I'm really pleased with how this came out. This was a pretty major undertaking, actually. There's a lot of stuff I did for the first time, and learning a circuit that has no layout and schematic is a bit difficult at first, but yeah, I'm really, really happy with how this came out, and I hope the owner is too. So, all right, I think we're gonna go ahead and end there. If we'll just end there. All right, until next time. See ya.